is America. Good afternoon. Good afternoon. It's great to be here. Wow. Fantastic. Good afternoon. I'm thrilled to be here with you tonight. Good afternoon. My name is Chris Lawler. I'm an electrical engineering student at the University of New Haven. We're going to be covering a lot of ground tonight. I appreciate it. If I'm moving too fast, tell me to slow down. This summer, I had the opportunity to work for transmission maintenance. I worked for the operational engineering department. My main project this summer has been circuit breaker condition monitoring. Today I'd like to tell you about the project and how I was involved. I hope that I'm able to convince you of how important circuit breaker monitoring is to our maintenance program. I'd like to start with a brief description of a circuit breaker. A circuit breaker simply interrupts the flow of current. It serves as a connection point in our electrical system. If there's a fault in the line, a circuit breaker the contacts within the breaker will separate to stop the current. As it separates, an arc can form as the current resists the interruption. There are different methods for breaking this arc, extinguishing this arc. Many of our breakers use SF6 gas or sulfur hexafluoride. The illustration on the left shows the SF6 as the breaker contacts separate. It's forced out in the path of the arc, and it extinguishes the arc. SF6 gas is very efficient as a dielectric, but it's also an EPA regulated gas. And for this reason, we need to be very cautious when we use it, and we want to avoid leaks and protect the environment. And the picture on the left shows an SF6 gas breaker, and we have many of these breakers in our circuit breaker fleet. Now I'd like to explain what the BCM is. The BCM monitors breaker operations as well as different breaker components. It will alert maintenance if it detects something wrong. If a breaker is taking longer to open, or if gas is leaking from an SF6 circuit breaker, we want to know about these things early on so we can take steps to fix the breaker before a failure occurs. So,
You got a meeting here today?
no, not at all. I was practicing for presentation.
Okay, now we just make sure all the projectors are all off. All right.
All right, thank you.
Have a good night.
Yeah, doing good, dude. Thank you. Here are a few things that we want to monitor. You want to monitor open and closing times. If a breaker's taking longer to open or close, that indicates that there's a problem with the breaker. Condition of the trip coils and the close coils. The coils are essential to breaker operation. If a coil fails, the breaker would not operate when it's called on. And as I mentioned, we want to monitor for gas leaks. Most of our breakers use a gas that's regulated by the EPA, as I already mentioned. We want to be cautious and stop leaks very quickly. Gas leak could also, if enough gas is lost, it could also cause the breaker to fail or not operate properly. I'll talk briefly about regulations that are affecting our company in a moment. And this picture shows a monitor installed on a breaker, and then I've also included screenshots of what the monitoring software will look like. Now I'd like to look at a breaker failure. This is a good example of a failure that could have been prevented if we had monitors installed on every breaker. This is a 345 kilovolt breaker located at a Schofield rock substation. Here you can see the operating lever. The lever seized and it would not close the breaker when it was called on. This incident, this failure, caused the breaker to be out of service for 2.5 months. If a monitor would have been installed on this breaker, we would have seen longer operating times, which indicate the problem. We would have been able to avoid a failure. This picture shows how bad the condition of the breaker really was. The electricians that were servicing this breaker actually used a bottle jack to try to close the breaker, but the lever would not move. Next, this incident shows a 150 kilovolt breaker located at a Barber Hill substation. The monitor alerted maintenance to longer closing times. On the left, you can see the alerts. On the right, you can see the trace and the inconsistency in the closing times. This breaker was taken out of service. It was tested and a new coil was installed. The breaker was tested again after the repair, and this is the trace of the closing times. Both traces show 8 closing operations. You can see the difference in the speed and consistency. The closing operations are very tightly grouped, very consistent after the coil was replaced. This is a breaker condition monitoring success story. The contrast of these two incidents really demonstrate how important having BCMs on breaker really is. How important it is to have BCMs installed on our breakers. As I mentioned, most of our breakers use SF6 gas, and this is regulated by the EPA. Strict regulations are being enforced in Massachusetts, but not yet in Connecticut. These are some of the regulations that are being enforced in Massachusetts. And as I mentioned, the BCM monitors for gas leaks and alerts maintenance if it is detected. Now I'd like to talk about some of the things that I did this summer in order to help with this project. I spent a lot of time learning about breakers and breaker monitors. I went to many different substations and worked with engineers, and I was able to learn a lot from the engineers in my department. After I felt that I had a good understanding of breakers and monitors, And after me and the other engineers had a good idea of what features we wanted in a monitor, I started to reach out to manufacturers about their breakers, about their monitors. I was able to help set up a meeting between operational engineering, the engineering department, and one of the manufacturer reps for one of the monitors. It was great to be able to work closely with engineers from different departments and see the different roles that the engineers have in a project. I was able to work with the engineer department more than once. Jason, Mother, as we developed our list of features that we wanted our monitor to have. Part of my assignment was to look at circuit drawings and figure out how to install the monitor and how easy that would be. So this is an example of one of the wiring drawings that I was using. We were provided a drawing of a new monitor installed on a breaker. One of the manufacturers sent that to us. And I compared that against one of the drawings that we have of an older BCM installed on one of our Manchester breakers. So here you can see the obsolete monitor. The wiring diagram shows circled in red are the points of connection for the new monitor, for the installation. So that was an interesting point that was a challenging point for me, was to get to that point where I was comfortable enough looking at the drawings, to be able to identify where we wanted the new monitor to be connected. Now, past experience, I've mentioned that we have obsolete monitors installed on some of our breakers. In the early 2000s, the company ordered many monitors, and the project failed due to a few different issues. And that may be a source of reluctance in the company to embrace a new circuit breaker monitoring effort. One of the reasons the effort failed was poor support from the manufacturers. Condition monitoring had not developed at the time, so it was a new field. Another reason was the monitors did not have remote capabilities, so the engineers had to go to each breaker, plug into each monitor to see what was going on with that breaker. This is not very convenient. The monitors have come a long way since then. There's many different manufacturers, and the quality of the product has increased. And also each monitor has online capabilities, so you can log into a browser. Log in using any browser, you can log into the monitoring software. Jason Thomas, thank you. In summary, BCMs provide continuous monitoring of breakers. As I mentioned, this helps us to find and fix problems early on. We're able to optimize our maintenance plans and comply with EPA regulations. I hope that I've been able to demonstrate to you all the importance of breaker condition monitoring. It is a very important part of our breaker maintenance strategy. I've had a great experience this summer. I was able to be part of an important project and have an impact on the company. I enjoyed working with engineers from many different departments. I enjoyed working with engineers from departments. I enjoyed working with many different people, both inside and outside of my department. I look forward to future opportunities to work for Eversource. Lastly, I'd like to thank some people from my department, Mr. Thomas Kenny, Mr. Brian Fluss, Mr. Mike McKinnon, and Mr. Kevin Harris. I'd also like to thank the Human Resources Department and the Transmission Leadership Team for making this opportunity possible. And I'd like to thank everyone at Eversource. Had a great summer. Thank you.